Good morning, everybody. Nice to see you here today. I'm James Duez. I'm CEO and co-founder of Rainbird. I'm going to talk a little bit about Rainbird later on, but really the focus of today's talk is to put in context, a few important topics in the space, including why it's important that these tools are becoming democratized, and how that's critical to bringing, functionality, but also trust to these kinds of tools. Every organization has aspired to be more digital pre-COVID. I think now we've all realized that's a matter of survival. I'm just going to start really by defining the term AI. There are numerous definitions of AI. It's really describes a very broad church of technologies and is something of an unhelpful label. But in this context, most people would consider AI is a machine that's performing an intrinsically human task, some task that was previously thought of as being specifically human. One of the troubles that we have with this definition is it is utterly self-defeating, because in the moment that a piece of technology can do something we thought was intrinsically human, it no longer meets this definition of AI. It's something known as the AI effect, a term coined by John McCarthy back in the 1950s. Just to put this into context, in 1996, Garry Kasparov was again beaten by IBM's Deep Blue computer at playing chess. There were people back then, I was a teenager, but I remember that there were people that considered that it would be the beginning of the end if ever it was possible that a computer could beat a human being at chess. And of course, in 1997, Garry Kasparov lost. What happened? The world didn't end, actually. We just recognized that chess playing computers are just better than people. We recognized this particular form of AI as being what it always was, which is just the next generation of computer science. We don't regard chess playing as something that humans are best at. You don't consider your sat nav to be AI, but there was a point at which it was considered that. And so in some ways, AI, as I said, in this unhelpful way, sort of describes technologies that are almost at the fringes. And some people would say it's almost describing technologies that don't quite work properly yet. But what I want to do is to really just focus on distinctly separating two main classifications in this space, because many businesses conflate them. A lot of people, when they're thinking about AI, are really talking about insights. They're talking about being able to find value in data, something that was opaque by other means. But also some people are thinking about automation, and that's really synonymous with efficiency. Now, both these aspects are useful and important, and of course they're intertwined. And the chances are you want to automate human decision work for efficiency, but you also want to find a better quality answers. You want to raise standards. These can be combined in such a way as to produce the three things that I would argue every organization wants. Everybody wants greater efficiency to reduce costs. Every organization wants improved outcomes for their customers so that they can grow loyalty and be competitive. And everybody's looking for new revenue streams. And we have a formula for this at Rainbow, which I'll be sharing with you during this talk. But let's ask ourselves, why is this important? This is important because it's actually very rare that there's a category of technology that can deliver all three of these things, even if that's not always in the same use case. And artificial intelligence is that category, but also intelligent automation is that category. And that's really where Rainbird fits. Let's try and bring this alive by talking about a specific use case. This is one that you might relate to. I imagine you may periodically get fraud warnings on your credit card. That's probably because some statistical machine learned algorithm has seen what I would describe as a glitch in the matrix. There's something that's happened on your card that it thinks is fraud. Chances are every single time I travel to New York on business, the first time I get my card out, it's not going to work. And that's because that's broken some pattern. Now, there are many, many false positives, and actually banks use humans to check what the algorithm has flagged, because if they actually alerted you for every single one of those alarms, you would not use the card anymore. And in America, where people have many, many more credit cards, they have this phenomenon where their card just goes to the back of the wallet and people don't use it. Now, actually, this is an example of where our technology was used to create a fraud tool that synthesized what these humans were doing in scrutinizing these transactions. So in that New York case, a smart person could look at my transaction and see my assistant bought tickets to New York, and I'm there legitimately. But of course, that's not evident in the data necessarily, and the machine learning algorithm can't see it. But we were able to take the 2 or 3 best performing people and build a human-derived model that not only was 100 times faster than the humans, but actually was 25% better in the quality of the decisions that it was making. And what's critical is the experts were central to the process of making this tool. Now, the bank turned around to us and said this represented a 60% reduction in global fraud processing costs in a project that was done in just weeks. And this same technology is being used by the big four accounting firms to create new digital products and services or automate tax decisions. It's being used in healthcare to support large numbers of decisions around COVID. In fact, right now we're looking at applying this to triaging the massive backlog of patients that are on long waiting lists. But it's the fact that the experts were involved in the process that's important, and that's why I'm really here to talk about democratization. Tools have gradually become democratized to the point where businesses can take advantage of them, and there is a proliferation of what's described as no-code or low-code tools that have taken these capabilities away from around AI, from the academic lab to the IT lab and data scientists, and now actually into the hands of business people. And this matters because when technical people and business people work together to develop a solution, stuff can get lost in translation. So the closer you can put the business expert to the center of the process of building tools, the better the outcome is going to be. There's a great article out there about why software projects fail and bridges don't, which I won't go into in too much detail, but is worth looking up. But the closer the business is to the development of tools, we know the better the outcome. And it's really the exponential pace of change that's meant that software needs to be developed in a very agile way, unlike bridges. People don't change their mind when you're building a bridge. They don't sort of say, oh, I'd like to have a walkway there now halfway through the design. But this can lead to a high rate of failure within software. And a great way of mitigating that is the business being much more involved. Robotic process automation, business process management frameworks, and now intelligent automation tools more generally have continued what maybe spreadsheets started and accelerated this phenomenon that we might call the citizen developer. The day has gone when the IT tail can wag the business dog. So businesses are adopting tools that are actually horizontal capabilities. They're not just point solutions that do specific things. You can buy a point solution that will help you identify fraud, but if you adopt a platform, then you can build a capability to solve multiple problems. And this is spawning centers of excellence and the creation of teams that are able to wield these low-code tools to more rapidly solve business challenges at great scale. There's some fantastic examples of these. Now, a positive side effect of platforms over point solutions is that they really help businesses avoid the next generation of technical legacy. They enable organizations to more easily build, integrate, and maintain solutions within that platform's ecosystem. These tools are also helping to offset a shortage in data science talent and skills. There's huge value in data science. We're not taking that away. We do need more engineers, but we also need more what we might call code DJs or low-code DJs, people with the creativity to use what other people have actually created and invested in, but in new ways to solve problems. That's absolutely been key. Coming back to machine learning, I want to just put a spotlight and maybe just for some give a little bit of a perspective on statistical predictions and why rules-based AI has a role to play. This is a very simple example. You can easily build a model, a machine learning algorithm that can predict how likely you would be to survive the sinking of a repeated Titanic disaster based on historical events. I think there's an open source data set somewhere, which is the details of everybody that was on the Titanic. You just pipe that data into a machine learning tool, and you can basically train an algorithm that can predict, what you would need to be most likely to survive. You'd want to be a first-class passenger, failing that second or third-class passenger. You'd rather be a woman or child than a man, and you certainly wouldn't want to be crew. Now, the algorithm has simply reverse engineered what ultimately were human-devised evacuation orders. And I think this is just a really good example to highlight that machines learning is most of the time, it's about rules extraction, even if you can't understand the rules that were created. There are times when machine learned predictions are very useful, and there are very powerful tools out there that enable you to do this data science without being a data scientist. We have a capability in Rainbird, it's called AutoML. We codename this Evelyn, which goes a long way to enabling business people to take a big corpus of data and create machine learning algorithms and make those more explainable. But you do need copious amounts of clean data to build machine learning algorithms, and many organizations still struggle and are not data ready. We must remember that for all the hype there is around AI, and machine learning, it's not magic. You can't wave a wand over unstructured data and have a machine impose order. Building machine learning algorithms is hugely labor intensive. And there's no escape from that. You have to prepare and tag lots of data, which is unfortunately most of the time a very manual task. Somebody actually once described it to me. It's a bit like climbing Everest. You need 10 years experience to get to base camp, and then after that you need specialist equipment, money, time, faith. And you know what? If you can build a machine learning algorithm, it's a fantastic view from the top, but it's fair to say that most projects die on the way up. And there's a few reasons why that is. One is the challenge of bias. Lots talked about bias. Everybody understands the nature of bias, but not everyone realizes just how many types of bias there are. According to Gartner, there are well over 500. My personal favorite is the IKEA bias, which basically says you're going to give disproportionate value to something that you've crafted with your own hands. But these biases make it very difficult to create machine learning algorithms that are accurate and fair, because the bias is hidden. It's kind of embedded in the data. And we can talk about accuracy and fairness, but actually more simply, we need to be able to build algorithms that don't break the law. And with bias embedded in data, that's quite difficult. It's actually the central point of a new Netflix documentary called Coded Bias, which I'd recommend. And there's lots of high profile and obvious examples of bias being embedded in data. Apple's credit card algorithm debacle of 2019 is a good example. But the problem is everywhere, and it is really bad. Harvard Business Review estimates that only about 3% of business data is actually clean. And a new MIT study found that the top 10 most used machine learning data sets are absolutely riddled with errors. So there are issues around machine learning algorithms when you're thinking about trying to use them to automate because of bias. But actually, it goes more than that. Okay, so there are trust issues with machine learning. It's not readily interpretable. I love this XKCD cartoon. You know, how do you know these answers are right? Well, you just keep stirring until they look right. You know, transparency is extremely important for any organization considering AI and automation, and the lack of interpretability that there is around machine learning, its inability to clearly explain itself to a layperson, it is a very big challenge. And, you know, history is full of examples of where we just don't trust technologies we don't understand. You know, we take microwaves for granted now. They weren't in common use until the late 1970s, early 80s, despite the fact that they were invented in 1946. Now they're completely safe. But, you know, I remember my parents not really trusting a microwave because people didn't really understand how they worked. So, you know, it's important that we trust technology if we're going to make good use of it. Now, while much progress is being made to make machine learning more interpretable, I would contend that it is an analysis technology, not naturally an automation technology. I mean, usually, right? So come back to Netflix. Netflix predictions don't need to be explainable. Netflix or anybody of those who's making using a machine learning algorithm to make a prediction may pay a commercial price if they get it wrong. But there's no regulator on the end who's going to slap their wrist or fine them for a breach of law. I have several daughters, and they use my Netflix profile. So Netflix has a very strange idea about what movie I want to watch next, because it's a combination of all our different tastes. But if you're making a decision that impacts a human, let's say in healthcare or financial services or insurance or around law, you better be able to explain how the computer made that decision, or regulators will have something to say about it. And with new AI legislation coming out, the EU AI Act is due in 2024, that the UK is going to be doing something similar. This is only going to go one way. So it's important that we don't confuse machine learning, which is synonymous with a prediction, with the application of judgment. You know, machine learning is predictive. It still requires a human on the end to generally to put their name to what that machine learning algorithm is predicting. So can we automate judgment? Well, traditionally, we try to automate human knowledge with very simple business processes, with decision trees. You know, these are business friendly. They feel very quick to build, at least initially. But anybody who's tried to build a decision tree that's in anything more than just a few levels will realize that they're extremely limited and very hard to build. They actually don't scale very well and are very, very expensive to maintain. Now, many organizations have challenges between their use of kind of linear decision trees and robotic process automation and what we might call very simple linear task-based automation, and their adoption of machine learning, which is commonly referred to as black box AI. You know, RPA is excellent at orchestration and automating very simple tasks, you know, replacing somebody keying one thing in one system to another. but it doesn't extend to smart, probabilistic, human-like reasoning. Machine learning algorithms, as we've described, are probabilistic, but they're not explainable. And it's always felt like there's this gap for a technology that can make complex decisions, but also be entirely explainable. And that's Rainbird. Rainbird is a human decision automation platform. And to some extent, to synthesize human decisions in an explainable way has been at the forefront of AI research. It's what we've been grasping for many years. So through Rainbird, it's possible for non-developers to build more holistic representations of knowledge. So not decision trees, but what we call knowledge maps, which can be used to apply judgment at scale. And we help people recognize quickly how and why this works. Now, we all make decisions as human beings. We actually make between 15 and 30,000 a day, because we can include all the trivial decisions like who's going to put the bin out and everything else, whether to have that slice of cake for lunch. We hold rules in our head. These are the results of our formal education, our experience with others, the rules we do our jobs by. And what we're doing is we're seeking data to judge, right? We're asking questions or finding the data we need. And then what we're doing is we make an inference. We're mashing together the knowledge we have in our head with the data that's available, having maybe ask questions to get more, to make an inference. Now, it may not feel like it's a mathematical process. We may think, my feeling is this, or I have this instinct, or whatever else. These are all false labels for what is actually a mathematical process, and it's one that can be replicated by Rainbird. So we do this by building not decision trees, but these knowledge maps that are reusable. I mean, we've got examples of models that can answer hundreds of different questions, including questions beyond the scope of what they were designed to do. But when they're queried, they are entirely explainable. And what's very powerful about this sort of automation is that if data is missing, rather than just failing, it's capable of constructing questions in English, because it is in essence a symbolic model. So asking questions and combining that data with the knowledge that it has to maybe surface other questions. So it creates a conversation, just like it does when you speak to a smart person. And then we can very easily test these models that we build at scale to try and visualize and see any bias that may be in there. And once we've built a system that we're comfortable doesn't have bias, we make everybody else use it to augment their decision making, and we insulate ourselves from the bias of users. We are poor at making decisions. This fact is validated by some of the most preeminent thinkers, including the Nobel Prize winning economist Daniel Kahneman. These are medical examples, but 2/3 of oncologists cannot correctly state the chance that you have cancer after a positive mammogram because they do not recall or understand the difference between prior and posterior probability. Probability is slippery. Even the most experienced radiologists make contradicting judgments about 20% of the time on seeing the same X-ray. Now, bias is part of this, but actually there's something called noise that gets in the way. We can be tired, we can be hungover, we can be stressed. They could literally be noise, a pneumatic drill outside the window, and this will impact the quality of our decision making. There is a huge hidden cost of inconsistent decision making in businesses. And as Daniel Kahneman says, the answer to this actually is algorithms. So bringing democratization and this powerful probabilistic capability together, here's a healthcare example. We created an intelligent COVID-19 occupational health risk assessment, which went from an idea to being live in multiple trusts in just 8 days. What you can see here that looks a bit like a mind map is a Rainbird knowledge map that was built in 3 2-hour sessions with a single expert. In this case, it was a gentleman who happened to be the Director of Quality for the Faculty of Occupational Medicine, so the UK's leading expert. And actually, it was built in 6 hours. It took the rest of the time to get it through a clinical approval process. And actually, it consults with you. So this model is a pure repository of logic. It manifests as a sort of something that you might think of as a kind of a quiz or a consultative interface. It consults with you about your personal circumstances as a frontline NHS worker. And nobody's scripted the questions this tool asks. We just taught the tool about COVID, and it constructs the dialogue. You can tell it how to ask these questions nicely. Because if it doesn't know enough about you, it's basically asking questions to get the knowledge it needs. And then at the end, it creates a series of PDFs for different audiences and distributes them with instructions on what to do. So, for example, this is a report from my manager that tells my manager what my risk rating is and how to protect me, but doesn't reveal all my medical information. Now, at a time where 1.4 million NHS workers needed to be risk assessed and there weren't enough occupational health staff around, this sort of automation was the only way you could achieve this sort of scale. And this is perhaps the smallest example of a Rainbird project, but it's testament to the fact that you can achieve a huge amount in a very small amount of time. And this has doubtless saved lives. And it's only possible because Rainbird can really make complex inferences like a human would. So getting close to the end then, so the formula that lets organizations achieve the three things they really want, and if you remember, that's efficiency, improved customer outcomes, and often new products, revenue, services. The format's gone a bit funny on this slide, but prediction, which is synonymous with machine learning, plus judgment, which is rules-based or typically human, which can now be automated through tools like Rainbird, is really how you get to truly automated decisions. And this actually all works best with technology and humans working together, which is what we would call human in the loop. You know, Rainbird is certainly about augmenting people to be ridiculously efficient. It's easy for technology to do that because it's fast, but also to include that everybody is as good as the best person, if not better, on their best day. And because Rainbird routinely outperforms the expert that built the model, you can dramatically have positive influence across a whole range of use cases. And of course, because it's democratized, once you build one project, you can then proliferate more. And you know, this frees up people to have greater impact, of course, where technology can't perform in areas like, you know, listening, building rapport, and being creative. So what are the ingredients for success when adopting these tools? Well, you need to ensure that you have a digital strategy that clarifies the organization's ambition. And as a minimum, you do need senior buy-in. There needs to be an automation champion or a center of excellence, as well as a problem owner with a critical need for change. These are the ingredients of a successful project. Now, the technologies look transformational because they are. You know, as soon as people see Rainbird, their mind is blown and they're like, well, I can think of dozens of use cases. You need to narrow that down and find a business case that has a clear return on investment that justifies getting involved. You need a painful problem that the technology can solve fairly rapidly, because actually by doing that, particularly if you focus on improving something in the organization before you try and be too transformative, you're starting small. And once the first project is successful, I guarantee it will quickly scale. That's what happens within our organizations. I mean, give an example, 3 out of the big 4 global accounting firms took Rainbird on for a single project and have now proliferated numerous projects around tax automation, around fraud, a whole range of areas. You're creating this new internal capability to transform yourself, but you need to be clear on what you're trying to achieve. You know, unbundle this analysis prediction from what you're actually trying to automate. Are you trying to make predictions based on historical data? Are you trying to automate an inefficient process? Are you trying to change the quality of a customer outcome? Are you trying to invent something new? So look, in conclusion, these tools are democratized. This does not mean that there's no IT involvement, but it does mean the business has to be central to the process of building systems, and the cat's out of the bag in that area. You know, AI and intelligent automation, IA, is not something to be feared, it's to be embraced, especially tools like Rainbird that are about empowering the business to help itself and focusing on transparency and auditability. And I think we need to recognize the difference between analysis and automation and that formula. You know, we can do more than use data to build algorithms we apply to humans, which is what a lot of people think about with AI. We can empower human experts to build algorithms that we can apply to data. You know, we can apply human judgment at scale to create automated decisions which are probabilistic, because, you know, the real world isn't black and white, it's all these messy shades of gray, but are also entirely explainable. And that's very much the focus and the philosophy of what we're working on at Rainbird. And we can do all of this ultimately by, you know, amplifying and empowering our best people. Thank you for taking the time to listen to me this morning. If you have any questions or are interested in getting on a Teams and Zoom, come build a model with me or one of our team. Please get in touch so you can learn more. You know, in half an hour, we can build something together which will dramatically accelerate your understanding, not just of Rainbird, but of this capability generally. So please do feel free to get in touch with any of these contact details. And thank you very much for your time.